the 7th of May, 2020, and I'm here for Mr. Kushu's 9th grade biology class, and today I'm going to be talking to you about enzymes. So, I have a little model here to show you what an enzyme kind of looks like. An enzyme is made out of proteins, and in your body it's designed to speed up chemical reactions. So, an enzyme takes a substrate, which is something that needs to be broken down or built up, and it helps it do it more quickly. So sometimes you'll have what's called an anabolic reaction, where you have two different substrates. And one goes into the enzyme first, and then you have another that comes down, and the enzyme helps it connect to the other piece, and then you have the product.
Yeah.
So before it was two pieces, and now it's one piece. And then you also have what's called catabolic reactions, which is when you have one piece, and the enzyme helps it break into two pieces, right? So then sometimes with an enzyme, something will get in the way of it. Like if you need, let's say this enzyme helps an infection or something, it helps make viruses in your body and you need to stop that, then you can design some sort of inhibitor. So you have two different types of inhibitors generally. You have a competitive inhibitor, which will sit in the active site. This area right here is the active site, where the substrate binds. And it will sit in here so that a substrate cannot go in because this is taking up space and it can't bind to the enzyme. But then you also have another type of inhibitor, which is called an allosteric inhibitor. And this will go into the allosteric site, which is this little cavity right here. Will bind in there like so, and now you can see the active site is significantly changed. So, if a substrate tries to bind with the enzyme, it can't, because the active site shape is changed and it can't fit in there. So you'll also have things called cofactors sometimes, which are little things that will attach to the enzyme to help it work better. These will be sometimes like minerals, like copper, and they just help the enzyme work more efficiently. So let's say you had an enzyme with a charge, like this. This side's more negative and this side's more positive. Which one of these substrates do you think would bond more easily? Well, you can see that it would be this one, because the positive side bonds more easily with the negative side, and the negative side bonds more easily with the positive side because opposites attract. Now, sometimes, like I said before with inhibitors, sometimes you might have an inhibitor that's permanent, say poison or something, and it fits in here to the active site, and now this good enzyme can't bind with the good substrates, and you can't make whatever your body needs to make, and that can be very, very dangerous. And I think we've gone over just about everything we need to go over about enzymes and substrates and allosteric and competitive inhibitor. Enzymes are very specific. In certain areas, in certain temperatures, they don't work as well. So a few factors that will affect how well an enzyme works is temperature, pH level, substrate concentration, and enzyme concentration. So for temperature, basically, if an enzyme is too hot or too cold, it will denature, which means it'll lose shape and it won't function anymore. For pH level, it's very similar. If the pH level is too acidic or too basic, then it won't be able to function because it has a special pH and temperature level that it needs to be in to work properly. And then also substrate concentration, say you have the more substrates, basically the more substrates you have, the more the enzyme has to work with. But eventually you'll reach basically a rate at which the level of productivity is saturated. The enzyme can't work any faster, it just works at a steady rate that it can break down or build up the substrates. And then also if you have more enzymes, of course, they can work faster just because there are more enzymes to work. So that's very important because enzymes are very specific in what kind of temperature and pH levels they can work in. Thank you.